Welcome to our deep dive today. And wow, are we going deep? We're
Oh.
tackling dark flow.
Yeah, dark flow. It's a fascinating concept.
It is, and it's one of those things in astrophysics
Yeah.
that, you hear about it and you're like, wait a minute. So
Exactly.
we're going to try to break it down for everybody today and look at, is it fact? Is it fiction? What do we know? What don't we know?
Right. And we've got some awesome research and articles that listeners have sent in.
Absolutely.
Yeah.
So to kind of set the scene, I want you to imagine for a second, those ancient humans huddled around a campfire.
Mm-hmm.
They're looking up at the night sky.
Right.
And they had no idea really what was out there.
Yep.
Fast forward to today, we have amazing instruments like the James Webb Space Telescope
Yeah.
that can peer to the edge of the observable universe.
That was incredible.
But even with that, there's still this darkness beyond, right? We can only see so far.
Absolutely. It's like this cosmic horizon, this limit to our vision. Yeah.
Right. And that's where dark flow comes in. Because it kind of suggests that there might be something massive hiding in that darkness beyond the edge.
Right.
That's tugging on stuff we can see, like entire galaxy clusters inside our observable universe.
Yeah, it's this idea that something outside of what we can see is actually influencing things within our cosmic neighborhood.
So wait a minute. Something outside of what we can see is affecting what's inside. How is that even possible?
Yeah, that's the big question, isn't it? And it all started back in 2008 when scientists noticed hundreds of galaxy clusters moving towards a particular patch of sky at speeds that just couldn't be explained by our current understanding of gravity and the distribution of matter.
Okay, so we can actually measure these galaxy clusters moving billions of light years away. That's insane.
It is, and they're not just moving randomly, they're all kind of flowing in the same direction, like they're caught in some invisible current.
Okay, so it's like a cosmic river then.
Exactly. It's like a river with a really strong current spanning billions of light years.
And this flow, it's not caused by anything we can currently explain.
Not really. Our current models of gravity and the distribution of matter just don't account for it. It's like watching a river flow uphill. It just doesn't make sense according to the rules we know.
Okay, so what are we missing then? Is there some dark force out there we haven't discovered yet or something?
Well, one possible explanation involves something called cosmic inflation. Have you heard of that?
Vaguely. I know it has something to do with the Big Bang, right?
Right. So imagine the universe right after the Big Bang. It was incredibly tiny.
Okay.
And then in a fraction of a second, it underwent this insane expansion, like going from the size of a bacterium to the size of the Milky Way galaxy almost instantly.
Whoa, okay, so the universe had a major growth spurt right at the beginning.
Exactly. And during that crazy expansion period, everything in the universe was connected, even things that are now billions of light years apart and beyond our observable horizon.
Okay, so it's like if you take two magnets and you stick them together and then you pull them apart really fast, they're separated, but they still kind of feel each other.
That's a great analogy.
Right. So is that kind of what we're talking about here?
Yeah, in a way.
Yeah.
Now imagine a really massive object, like a gigantic cluster of galaxies, existing outside what is now our observable universe. During that period of cosmic inflation, it had a chance to exert its gravitational pull on our little patch of space.
So you're saying there's a cosmic ghost out there, something we can't even see that's pulling the strings. And we're still feeling the effects of its gravity billions of years later.
That's the general idea. It's like the imprint of that ancient gravity is still lingering, causing the dark flow we observe.
Wow, okay, my mind is officially blown. So that's one explanation. But is everybody on board with this cosmic ghost theory? Is this a done deal in the scientific community?
Not so fast. There's a lot of debate about whether dark flow is even real,
Wait, so you're telling me scientists are looking at the same data? And some are saying dark flow exists, and others are saying, nah, it's a fantasy.
It happens more often than you think.
Really?
How is that even possible?
It comes down to interpretation, really. You see, the universe is a messy place.
Yeah.
Especially when you're trying to study something as vast and complex as this.
Right.
The data we get from telescopes isn't always crystal clear. There's noise, there's potential for error, and sometimes different teams can look at the same data and just come to different conclusions.
So it's not just about the data itself, but how you read it, like those optical illusions where you see one thing, then you see another.
Exactly. And one of the biggest sticking points with dark flow is this question of uniformity in the universe.
Okay, back up a sec. Uniformity, what do you mean by that?
Right. So our current understanding of the universe is based on this idea that at its largest scales, everything's pretty much the same everywhere. If you zoomed out far enough, it wouldn't matter where you were looking. The distribution of matter would be roughly even. Okay, yeah. That makes sense. But how does dark flow mess with that idea?
Well, if there's this massive cosmic ghost out there pulling on galaxy clusters, it would mean there's this huge concentration of matter in one particular direction.
Oh, I see.
And that kind of throws a wrench in the whole uniformity thing.
Right, it would be like finding a giant mountain range in the middle of what you thought was a perfectly flat plain.
Exactly. It changes everything. And that's one of the reasons some scientists are skeptical of the whole dark flow idea. They argue that if it's real, it would require us to, rethink some fundamental assumptions about the structure of the universe.
Okay, I'm starting to see why this is such a controversial topic.
Eh?
It's like we're at this cosmic crossroads, and dark flow is pointing us down this really weird path.
Yeah, it's definitely a mind bender. And to make things even more complicated, there's another piece of the puzzle we have to talk about, the Planck mission.
Planck, remind me.
So Planck was the space observatory launched by the European Space Agency back in 2009, and it basically created the most detailed map we have of the cosmic microwave background radiation.
Oh, right, the baby picture of the universe. We talked about that a bit ago.
Exactly. And this is where things get interesting. The Planck team analyzed their data, which was way more precise than anything we had before, and they found no evidence of dark flow.
Wait, what? But you just said that scientists are looking at the same data?
Well, not exactly. The team that originally discovered dark flow was using data from an earlier probe called WMAP, and that data was less sensitive than Planck. So some people argued that the dark flow signal they were seeing might have just been noise or a statistical fluke.
Okay, so better data, no dark flow, case closed, right?
You'd think so,
Yeah.
but the scientists who first discovered dark flow, Alexander Kishlinsky and his team, they're not giving up.
Really?
Yeah, they still believe they see signs of dark flow even in the Planck data.
Hold on, rewind. They're saying dark flow is hiding in the data even though the Planck team says it's not. How is that even possible?
Well, they argue that it all comes down to how you analyze the data. They're using different statistical techniques and focusing on specific scales, and they claim that if you look at it their way, the signs of dark flow are still there.
Ugh, okay. My brain is starting to hurt. So we've got two groups of really smart scientists, both using incredibly powerful technology, and they're coming to totally opposite conclusions. It's like they're speaking different languages.
In a way, they are. And it just goes to show how complex this whole thing is. You know, when you're dealing with something as vast and mysterious as the universe, there's bound to be disagreement and uncertainty.
So where does that leave us? Is dark flow real or not?
Honestly, we just don't know for sure yet. We need more research, maybe even more advanced telescopes and analytical tools.
Okay, so it's a cosmic cliffhanger for now. But even if we never definitively prove or disprove dark flow, what have we learned from this whole search?
Actually, quite a bit. It's
Yeah.
forced us to really examine our assumptions about the universe. You know, is it really as uniform as we thought? And it's pushed the boundaries of our observational and analytical techniques. You know, it's sparked important debates about how we interpret scientific evidence and how much we can really know about the universe.
It's like even if there's no pot of gold at the end of the rainbow, the journey itself has been incredibly valuable.
Exactly. And who knows, maybe this is just the beginning. Maybe dark flow is just the first hint of something much more profound, something that will completely revolutionize our understanding of the cosmos.
Okay, now you're giving me chills. What kind of something are we talking about here? So much to think about. I mean, we've gone deep into the data, looked at all sides of this dark flow debate. But I'm always curious about the so what, you know? What does it all mean for us? If dark flow is real, what does that change about how we see the universe and our place in it?
Well, it would definitely shake things up. I mean, if we confirm that there's this force out there beyond our comprehension pulling the strings of the cosmos, that means the universe is even weirder, even more mind-boggling than we ever imagined.
And our observable universe, you know, the part we can actually see and study, that would just be a tiny sliver of a much, much bigger reality.
Exactly. It would be like, well, imagine thinking the Earth is flat and then discovering, whoa, there's this whole massive globe we were totally unaware of.
Like that, but on a cosmic scale.
Yeah, exactly. And it would mean that everything we see, the galaxies, the stars, maybe even the laws of physics as we understand them, might be shaped by forces we can't even detect. We'd be like ants crawling on a leaf, totally oblivious to the vast tree we're a part of.
Wow, that's a powerful image. It makes you feel both incredibly small and incredibly connected at the same time.
It really does. And it opens up so many questions. What else is out there? Beyond our cosmic horizon, what other forces are at play that we haven't even begun to imagine?
Okay, my brain is officially fried. But even if dark flow turns out to be a cosmic illusion, this whole deep dive has been incredible.
I agree. It's a perfect example of how science works. We ask questions, we gather evidence, we debate, we revise our theories, and sometimes the most important discoveries are the ones that completely challenge our assumptions, the ones that force us to rethink everything we thought we knew.
It reminds me of that Carl Sagan quote, "Somewhere something incredible is waiting to be known." And maybe dark flow is a clue that's leading us toward one of those incredible somethings.
It very well could be, whether dark flow is a real phenomenon or a scientific dead end. The search itself has been so valuable. It's expanded our knowledge. It's pushed us to think bigger and bolder about the universe. And it's highlighted the fact that we still have so much to learn.
Well said. So as we wrap up this deep dive, what's the one thing you'd want our listeners to take away from all of this?
I think it's this. The universe is full of mysteries. The more we explore, the more we realize just how much we don't know. But that's what makes it so exciting. There's always something new to discover, something to wonder about, something to keep us pushing the boundaries of knowledge.
Absolutely. So to all our listeners out there, keep those cosmic questions coming, and we'll see you on our next deep dive into the mysteries of the universe.